Hello, everyone. Welcome to EdTech session by Cohere Community. I welcome you all in today's session with Dr. James. Uh, for the introduction, Dr. James is an award-winning writer and an educator with over 12 years of experience working in higher education. He holds a PhD in creative writing from UNSW and is a senior fellow of the Higher Education Academy. He currently serves as an education specialist in artificial intelligence at UNSW College. Thank you so much, Dr. James, for joining us today. We are very excited to have you.
All right, thank you. I'll jump straight into it and share my screen. Let's see.
Perfect, thank you.
How's that? Can you all see that?
Yes.
Fantastic. All right, well, thank you for having me. Yeah, it's great to be here on the CoLabs sessions. I've watched a couple on YouTube, so I'm feeling very out of my element as a teacher. But hopefully my non-technical explanations will suffice today. I'll try and move through the session so that we can get to some Q&A at the end, because I always enjoy questions from the audience and things. So if you do have questions throughout, please keep them in mind for the end, because I do enjoy chatting about the work that we've been doing. So as was mentioned, I've been working in higher education for the past 13 or so years. And yes, my background is in creative writing, so it's a bit odd sitting here today talking to you about EdTech. But my interest is really has been around learning and teaching, and over the last few years, AI in education. And I've worked with organizations and people to help them sort of untangle this Gordian knot that we find ourselves untangling, which is the idea of using AI to support learning. And I guess I was thinking about it recently. My interest in AI in education seems to have really sort of honed in on this idea of not so much like students going and using like consumer AI products, but more so in what happens when teachers are using AI to build their own solutions and their own learning resources. And I think that's a really interesting space to explore. So the main thing I want to talk about today, as is the title for today's session, is vibe coding and what it means for education. And as a former teacher working within the sector, I've seen a lot of interest in this area, but not a lot of guidance. And I've got a lot of firsthand experience as a quote unquote vibe coder working with staff, students, trying to develop whatever this term is and what it means, and trying to create projects that really just build on this idea of being able to code using natural language. So I'll talk about, I guess, what this means for teachers and hopefully how we might be able to take advantage of it, because it's not all smooth sailing necessarily, as I'll sort of talk about. But yeah, just to flag, I'm not here to suggest AI in any way replaces the teacher in any instance. In fact, the more I think about it, the more I see AI as like a sort of much smaller, less important resource off to the side that students can go and refer to occasionally. Whereas it's the relationships that they build with their teachers and their institutions, I think, are the most important. But I am very excited about this idea of vibe coding and what it means for people like me who have no idea how to code. So I'm going to try and explore this idea based on a few projects I've worked on. One in particular is called the Math Assistant, which I'll try and demo today, and really try to explore this question: what happens when people can build their own EdTech solutions, and what does this mean for education at large? So I will move on to the next slide. Let's see if that works. There we go. So this is a bit of a provocation. Some of you may have heard of this study before. But it goes a little bit like this. So one of the biggest predictors of improved student outcomes in a school wasn't the laptops or the learning management systems or even like those smart whiteboards that they used to have. It was aircon. So that's the thing that makes a room less hot. So basically they found that when the body is struggling to thermoregulate, I think is the term, the brain has fewer resources for complex tasks, and it sort of becomes physically harder to concentrate or retain info. And then all of a sudden they discovered, and I discovered this article through Jared Cooney-Holbath's Digital Delusion. I always struggle to say his name, which I highly recommend. But it basically finds that aircon was better than giving students a laptop. Now, I'm telling you this because I think it's funny, but also because I think it's really important that the relationship that we have, with technology and education sort of doesn't get forgotten. I think EdTech is in a really weird place at the moment. I think we've been buying into it for a long time and sort of under this assumption that, better tools produce better learning and there's some evidence for that, but it's a bit patchy. But I think if we're being objective about it, it could very well be that in the worst case situation, EdTech could potentially harm learning, and we're seeing a lot of that coming out in recent studies. So with articles being redacted and things, some of you may have been following. So we're spending a lot of money on platforms, and often they surveil students and they might disengage them, and often they attempt to make the learning easier and even strip out the relational fabric that comes with teaching altogether. If you've watched the news recently, you'll notice that EdTech it's facing a bit of backlash. There's been some talks about Carnegie, which has been making headlines. I guess there's an overall sentiment I've been feeling anyway as I read these articles online that EdTech is starting to slump, depending on who you talk to. There was a really good blog post by Dan Myers recently sort of pointing this out, and it was quite sobering actually, because he sort of shared this idea that despite all the money that Carnegie possessed and all support and resources that went into it, it kind of really struggled to support students in the way that everyone believed it could. So I think that should not necessarily signal alarm bells, but it should tell us something about putting in all our kind of time and effort into this idea of EdTech being the sort of savior for us all. So, but I don't think it has to, all go south. I think, and this is where I think vibe coding comes in. We're sort of at this moment in time where EdTech is I would say, facing some of its harshest criticism, and yet the barrier to entry in terms of building alternatives is like very, very minute right now. And so I'm kind of wrapping my head around whether or not this is necessarily a good thing, because I've seen some really bad examples, but I've also seen some really good examples, enough good examples to sort of excite me about the sort of potential here that exists when teachers and students work together to create their own EdTech solutions. So I think that's worth exploring. So I don't think the world needs, slightly worse versions of Kahoot built by people who vibe coded something for 5 minutes. I think the world needs teachers and students working together to build these EdTech solutions that are relevant to their context, their cultures, and the needs, the specific needs of their institutions. And I'll talk more about what this means in relation to entanglement pedagogy a bit down the track. But so I guess the question is, can vibe coding act as a bridge to this sort of EdTech utopia where students are kind of, working with teachers and learning designers to become builders of their own, learning solutions, which is something we actually did with our math assistant, which I'll demo later on. But I think it's important to sort of unpack a bit of theoretical framework around the why of these tools and what they're doing, rather than just showing you the tools themselves. So just laying the groundwork here, just bear with me for a minute. Wanting to talk about self-regulated learning. So before I got into vibe coding, I was very interested in self-regulated learning. And I guess one of the things that frustrates me around the whole AI and education discourse is how often the theory gets skipped, or how often the sort of pedagogy gets skipped. We jump straight to the tool and get really excited about what it can do, and things can sort of not end up going too well if we sort of focus only on the tools. So in terms of self-regulated learning, some of you might be familiar with Zimmerman, his work. He provided this model which kind of gives us 3 phases. He called them forethought, performance, and self-reflection. In the forethought phase, you set goals and you plan and you activate prior knowledge. In the performance phase, you execute and you sort of do the work, you monitor how it's going. And in the self-reflection phase, you evaluate the outcome. So you adjust, you figure out what to do differently next time. Now that cycle, that sort of forethought and performance and self-reflection, it kind of maps really well to this cycle I've sort of come across with building things with generative AI. And I'll talk about a sort of framework that I'm developing around actually guiding that process. So when I'm sitting down to vibe code an educational tool, I'll often start by thinking, what do I actually need? What's the learning problem I'm trying to solve? Who's it for? What should it do? That's the forethought part of things. And then I go and build it. I prompt, I iterate, and I test. That would be the performance part of Zimmerman's models. And then you kind of step back and you ask, did this work? Did it do what I needed it to do? Where did it fall short? And that's the sort of self-reflection part. So the point I want to make with all of this is that, when we talk about vibe coding in education, we're not just talking about production process. We're talking about a learning process. So the educator is building a tool for their students, and that involves pedagogy. It involves a gap being filled and discovered. And I guess in other words, I believe if we build these tools alongside our students, there's a kind of learning that happens with the students as well that is very, very something we should kind of think about. It's very useful and beneficial. So this idea of, I guess, a second theoretical lens before I go into what we built and how we built it, is this idea of cognitive load. Now, some of you might have seen a paper that came out recently, perhaps not, but it's by Jason Lodge and Leslie Lobel on the Australian Network for Quality Digital Education. So I can say I'm Australian, I'm biased, but Australia is doing a lot of incredible work in this sort of space between AI and education, if you're not following. And this is a really great article on this idea of cognitive offloading. I would go as far as saying it's probably one of the most important distinctions I've seen about AI and education so far. So yeah, I would highly recommend reading it. But basically what Lodge and Lobel are saying is they sort of distinguish between this idea of what they call a sort of beneficial offloading and a detrimental offloading. So not all offloading is bad, in other words. Beneficial offloading is sort of when a student or even a teacher, when they use AI to sort of handle the extraneous stuff, so the formatting, the grammar checking, maybe the layout of a reference list, they're the sort of things that can consume working memory, but they don't really contribute to the actual learning, depending on what it is that you're measuring. So when you offload that, you're freeing up cognitive resources for the harder thinking and the intrinsic work. And there'll probably be some purists that will argue that formatting a reference list is part of the learning process. So I'm happy to debate you afterwards. But if you've heard of this term, intrinsic work, you'd sort of know that when you offload extraneous stuff, you free up this working memory for the more cognitively demanding part, which is where the actual learning happens. The schema construction is often called. So that's wrestling with concepts, making connections, and these are all really, really important. And by the way, this idea isn't new. There's a lot of research around it. Mueller and Oppenheimer, I think, is one of the most cited. And they show that students who take notes by hand, some of you might have seen this, they retain more than students who type. So I personally am I take my notebook everywhere. I handwrite notes all the time in meetings, close my laptop, that sort of thing. And the reason is because, mapping, it sort of maps directly onto this framework. When you type, you can sort of, you're transcribing almost verbatim what's being written. So the words pass through you, without much processing. You can obviously write more. But when you write by hand, you can't actually keep up with, what the lecturer is saying or what the YouTube video you're watching is saying, unless you pause and rewind it, of course. So you're kind of forced to do this sort of compression and selecting and rephrasing, and that's where learning and retention happens. I mentioned this because this is something we actually embedded into the Math Assistant, including a kind of handwritten feature. So I'll demo that soon. Now then there's the detrimental offloading. So there's a beneficial offloading, there's the detrimental offloading. And we sometimes refer to this as outsourcing. When you hand over something to, say, intrinsic cognitive work, that's not necessarily a good thing all the time. when you ask the AI, if write me this essay, solve this problem, do the thinking for me, that's when we sort of start to passively accept the outputs and we don't really engage, we don't learn. Now that might be okay if learning isn't your goal, but if it isn't, there's a problem. So I guess the generation of ideas and the retrieval of knowledge, the analysis of connections, all of that gets bypassed when we offload things detrimentally. And then the student completes a task, but they haven't really learned anything, right? So we're seeing this play out more and more, I think, with consumer-based AI tools that aren't necessarily designed with pedagogy or learning in mind, and students are erring towards these tools rather than the pedagogically aligned generative AI tools that we're building. So that's one of the challenges, is how do we actually get them to use the tools that encourage the learning. So yeah, Lodge and Lobel, they sort of describe what they call this performance paradox, and AI can boost the student's performance on an immediate task, and their essay might look better. They might get a high mark, but it obviously might damage their long-term learning, so they learn nothing. And we saw this in a number of papers on using AI to learn mathematics, where there was some short-term benefits, but ultimately long-term, the benefits sort of started to subside. So the reason this happens, because the cognitive struggle that often feels, I guess, inefficient at times, the part that feels frustrating, the part that EdTech often tries to solve and make better, that's how learning happens. We hear about the idea of learning needing to cause friction, and I guess you know that feeling of being exhausted mentally when you're learning a new subject. That's because you're learning. So when you remove all that struggle, you end up harming that process, and we don't want EdTech to do that, and we especially don't want students doing that. So where does vibe coding come in, and how does it actually help? I guess here's where I think AI and vibe coding has sort of something useful to offer. I think there's 2 points. Firstly, when an educator builds a tool using natural language, the AI kind of absorbs the extraneous load. So going back on that cognitive offloading theory. So it's kind of interesting, you're not having to learn JavaScript. You don't have to understand deployment pipelines necessarily. You don't have to, format CSS things for 3 hours trying to center a div. Like the handles, the AI sort of is handling all that. Now, what that means is that the educator's cognitive resources, then, thinking of people who don't know how to code, can actually be directed towards the pedagogy, and that's great. So, thinking, what should the tool do? How should they interact with it? What does the good learning experience look like in this context? So the second point, in terms of vibe coding and education, is that we built our math assistant, which we literally just called math assistant. It's a pretty boring name, but our tool uses translanguaging. So we specifically chose translanguaging as a feature to actually reduce the cognitive effort to learn math, because our students have English as a second language. So we kind of built this into our math assistant in a way that we knew would help them learn. And we didn't just ask, we didn't just get our math assistant just to translate everything into the student's first language when they were talking to it. We were careful with how and when things were translated. And we knew to inbuilt that feature because we were teachers and we work with students on a daily basis, and our students had specific needs. So that was something we were able to add in. Now, all this redistribution of cognitive effort with language is I think genuinely significant. I think it's something that there's the literature on vibe coding hasn't yet fully caught up with. And most of the discourse is sort of more about what you can build, but I'm interested in, I guess, what you learn by building it. And so I'll talk more about, bringing students into that process. So I guess the title of the session was around this idea of University 3.0, which is a kind of throwaway idea, really, but it's this idea that and I've been using it for a while. I don't know how well it holds, but University 1.0 is this sort of, the transmission model where you have the sage on the stage, the content delivery, the lecturer talks, the students listen, assessment checks whether they can produce what the students heard. We've seen this model play out before. Many of us were educated in it and served a purpose, still does. I personally love sitting in lectures and sitting there with a room full of people and engaged in the learning process, but things are changing. University 2.0 is the more digital transformation wave we're seeing, where learning management systems, lecture recordings, online learning, discussion boards, all that stuff. The technology kind of arrived and there were all these promises that came with it. But in many cases, what we kind of actually got wasn't necessarily what we thought we'd get. And so we have, I guess, pedagogy not really matching up to what we had necessarily planned. Now, University 3.0 is a kind of this idea that I guess is where we are finding ourselves now. And it sort of centers on this idea of what happens when the people can, closest to the learning problem have the tools to build a solution. So when technology, we don't just need to necessarily now purchase technology from a vendor as imposed, from the above or the previous eras of the university, but we can co-create as educators and students and learning designers to respond to our actual specific, like, local needs. And I think that's a really, really fascinating idea. So what if universities had their own dedicated teams who were developing and building their own EdTech solutions instead of just going out and purchasing this sort of one-size-fits-all approaches? Now, to sort of center this a bit more, I think I've written about this briefly, but it's really something that helps me frame what I'm kind of talking about when I say students can learn from the process of vibe coding. So Tim Fawns, he has this concept he calls entangled pedagogy or entanglement. It comes from a really well-known 2022 paper. And so the core argument is this idea that technology or teaching methods, they can't really be meaningfully separated. They're entangled. They shape each other. The values, the purposes, the context of an organization and the technology, they're all entangled together. So what this means is, I guess, a one-size-fits-all EdTech product isn't always going to be the best fit, because it can't sort of account for that entanglement that exists. So it's the kind of, some EdTech solutions are designed for a general use case for students. Vibe coding, I think, and this is where it sort of adds an interesting layer to that idea of entanglement pedagogy. Vibe coding is this idea that, well, at least I think, when you give teachers the ability to engineer their own solutions or build their own solutions, it's almost like we have, like, technology can then finally become entangled with the actual needs of your 30 students in the classroom or whatever it is, rather than sort of having to adapt, our pedagogy to a platform. We can sort of build a platform to fit our own pedagogy and our own needs. I think Fawns would probably insist that this only works though if it's done collectively, and that's a really important part. So when I talk about Math Assistant and how we built it, it wasn't just some person in silo. It was working in collaboration with others, which is where a lot of the learning happens. So we don't want teachers as solo builders. We want the teachers, the students, the learning designers, all working together to sort of negotiate this process together. Because I guess the entanglement of the technology and the pedagogy is going to happen regardless. But it's going to happen whether you plan it or not. But the question is whether that entanglement gets negotiated in ways that are going to produce good outcomes or bad outcomes. So that's the kind of thing I wanted to capture. I don't have my slide for the 3Ps. That's unfortunate. So if I did have my slide for the 3Ps, I'll go back here. I was going to talk about my framework for vibe coding. So basically, it's pretty simple. This is the way I frame how to approach a vibe coded project if you're working with other people. But it's called the 3Ps. It's prompt, prototype, and problem. So prompt is, I mean this in the sort of in both senses of the word. Before you open a single AI tool, you need to articulate the learning problem that's prompting you to build it. So it's not what would be cool to make, it's, what is the actual gap between where your students are and where they need to be? What kind of intervention is going to work, if any, right? What might close that gap? The double meaning is deliberate. I don't actually mean start with prompting. In vibe coding, the quality of what you build is I'd say directly like downstream of how well you can articulate what you need. And articulating what you need is a pedagogical skill, not a technical one. So this is where most vibe coding projects, I think, go wrong. In my experience, people go straight to the building, they get excited by what it can do, and they forget to ask where the thing they're about to build, whether it's actually going to do what they think it is going to do. And you can kind of get lost in the tech itself and not the solution it provides. So, prompting, why are you trying to build what you're trying to build? The prototype is you describing the solution in natural language and a working version appears, ta-da. And I still think that's just remarkable. I still find it astonishing. But the key insight here is it's not so much the speed of production, although that's really cool. It's what that speed of production makes possible. So because you built this thing in 20 minutes, you can throw it away in 20 minutes, right? The prototype is disposable. It's not precious. It's no longer precious. So you don't need to spend all this time developing this solution that then, realize this is actually working. And that's very exciting. The changes, I think this changes everything. It changes your relationship to what comes next, what you need to do to change things. I think you still need to be careful. Obviously, like you could lose, it's very easy to lose sight of the pedagogy when you're vibe coding or building an EdTech solution from scratch. I've found myself, chasing suggested features that AI might come up with, or, just forgetting to anchor myself in that sort of, in the problem I'm trying to solve. I've seen projects collapse, and, firsthand. So, but I'm definitely excited by what the tech can do rather than, what problem it's addressing. So, now the problem, so the 3 Ps, we've got the prompt, prototype, and problem. Problem is sort of where you want to put, ideally, you want to put in front of people, ideally students, and you want to find the problems. In other words, like, I'm not talking about like finding problems as in like bugs in a technical sense. Those are important too. I'm talking about sort of misalignments between, I guess, what like you build and what the learning actually requires. So, the interface, I guess, we assume prior knowledge sometimes students don't have. The bot might be answering questions when you really want it to guide Socratically. The scaffolding might be too tight or too loose. The instructions might sort of go, this way or that. These are all problems, right? The first version's never gonna be the final version. Obviously, it's almost always wrong, the first version. So that's not a bad thing. That's part of the process. So the problem, the third part of the 3 Ps is sort of articulating what the learning needs that your students have are, and then you're sort of back to the prompt. You're not starting over. You're starting again. So the problem sharpens the prompt reshapes the prototype reveals the new problems, and this is the kind of cycle that I find myself works well for vibe coding educational solutions. Now, I do want to talk about the 95% rule, and then I'll get to some questions in a sec, because I think this is really important to sort of preface that I don't think vibe coding gets us all the way there, and this raises a lot of issues, which I'll talk about, which I don't think universities are really thinking about just yet, but they will very soon. So I guess when you vibe code something, for those that do vibe code, and really lack that coding ability without the ability to vibe code, is that vibe coding gets you 95% of the way there. So it's a working product. It's a prototype. You can whip it up in a weekend sometimes, sometimes less, and it's very tempting to stop there because it's like it looks pretty good. It functions. It mostly works. You can show it to someone and they'll be impressed. But that last 5% is where I guess the most important work happens. That's where all the quality lives. That's the kind of, chasing the sort of edge cases and making sure it's accessible, and that it's a thing that students are going to want to use. Also, assume students just will always use it in ways you did not anticipate, as many of you probably experienced. But I think critically that last 5% is really where the deepest learning happens. And we go back to that entanglement pedagogy, for the students involved. That's really vital. So don't skip that last 5%. It's easy to get a prototype, but that last 5% is very vital. Okay, so I'll get sort of more practical for a minute. And if you're an educator or a learning designer or someone who supports teaching and learning, you want to all start doing this, and that's asking what do you actually need. So we sat down. First, before you build a sort of framework, for vibe coding, I've sort of been thinking of these questions that I think are useful. So questions like, what is the specific learning problem that the tool is meant to address? Who's going to use it, in what context, what data will it collect, all that thing. What's the exit strategy? Like if you're building a tool and then that person leaves the organization, what happens then? So these aren't very, they're not technical questions, but they're things to consider when you're building a project out. Often we don't think about the governance questions. I've got the wrong slide up, sorry. So these governance questions might not seem that interesting when you start building out your vibe coded artifact, but they're very important to consider, because eventually if this idea plays out, and I think it is, teachers, not all teachers, but some are building their vibe coded educational tools. We're going to soon have this sprawling ecosystem of educator built applications. So that means there's going to be security protocols, there's going to be privacy issues, intellectual property, concerns, lawsuits. All of that's going to get very messy. I don't think we're really prepared for it. Definitely check your organization's IP clause on employment. But I think it's really important to think about when you're building something, and when you start to build something, because these things will come up later on. Okay, I think my slides are a bit out of whack, so I'm sorry for that. I'll blame that on Claude. Obviously, you can tell these are vibe-coded slides, just going with the theme. I'll leave that up for now because that will give you an idea of what Math Assistant actually is. So in terms of knowing how to facilitate this sort of co-designing process, which again is really important. We don't just want teachers building in silos. This is where all the learning happens. I think learning designers already sit at this intersection of pedagogy and technology and institutional context. They know how to translate between what a teacher wants and what the tech can do. Vibe coding gives them, I guess, an additional superpower. And then, instead of iterations taking weeks, it can happen in a few hours. So that's very exciting. But I think co-design means bringing students into that process, and that requires a very different kind of facilitation. It means you've got to let the students break the thing. They're going to tell you why it's broken. They'll tell you very quickly. And it requires you to kind of treat that building process as a learning activity in its own right. So you're not just producing the artifact as part of the building that the students get to learn. So when students participate in this process, two things happen. The first is cognitive. They've got to articulate what they actually need to learn and how, which is a really powerful act of learning in and of itself. The second thing is there's a metacognitive element. So as the tool is tested and broken and rebuilt, which is part of that process, they're going to develop the capacity to sort of reflect on their own learning process. What worked, what didn't, why, that sort of thing. So this iterative cycle, is sort of mirrors the 3 Ps I was talking about, the prompt, prototype, problem. And when you make that visible to students, I think they start to see, the tool is being built in response to their feedback. They get excited about that, and they start to invest in the learning. And the fact that they're part of that building process, it's a motivator for learning. So And they're no longer like consumers of the platform. They're starting to be co-creators, and that's the part that I think really excites me. And I think that's where the sort of the real promise lies. So I've been talking for ages. I'm gonna just quickly show you Math Assistant. And if there are questions, I'm like happy to answer them. So I'm gonna jump out quickly and share my screen so you guys can see. Where are we? Sorry, I just stopped sharing. Let's see. Okay. Okay, so here is our Math Assistant. You guys can all see that. This is basically set up in Google AI Studio. We're using our own API key, so nothing is being trained on the inputs that we're getting. There's no data collection, no retention of information. It's just a web link we share with students with the password. It is designed with a handwritten mode. So students, we recommend use a tablet when they come into class. And I'm not going into depth because I don't want to bore people, but this Math Assistant wasn't just built as a kind of ad hoc thing to just kind of throw over to students to use as part of a course. It was embedded into the learning program itself. So we have a fundamentals math course at UNSW College. We wanted to help students, just give them a resource to help them after hours when teachers weren't available. And the core part of the technology is that it's embedded into the weekly curriculum. So you can kind of draw here. You can draw like, do some Pythagoras theorem. I'm drawing with my mouse, so it's really average. And then you can screenshot that and use it as input. We've hooked it up to Gemini Flash and Gemini 3.0, both really like powerful models when it comes to mathematics. And there's some really strong guardrails in there around the Socratic method, but we also thought it was really important to have an explicit method which actually walks students through the problem step by step. We know students are going to do that anyway, so why hide that feature? And I think some math problems actually do warrant actually going through and seeing that thought process. The other cool feature I really enjoy is the mystery problem. So this is just to kind of show you the power of our Desmos calculator and image generator. We've hooked it up to an image generator which creates a problem for the students to solve, and we can then feed that into our Desmos calculator. So while it's generating, I'll just quickly show you this. This is our Desmos calculator. It's going to soon, once it's ready, allow us to map this problem. So this is the alchemist's courtyard. So it gives the students a little bit of a problem. And then I'll just quickly ask it to graph in Desmos. The issue with live demos. And should put this problem into the calculator. There we go. So now we have a little visual of the problem that was being spoken about previously. So I might stop talking there. If there's also a feedback, like, once the student's sessions is finished, they download a feedback report. They can download a marked down file of the conversation for further iterations. The conversation's not saved, so as soon as they exit this, conversation's lost. We're not collecting student data, although that might be something we do in the future if it's worthwhile. But the feedback feature students also found and really helpful, something they came up with just to wrap up the session and give students a practice problem they can download and a few insights into their conversations. So there's also voice mode, which is really useful for our students that have English as additional languages. So but yeah, I'll wrap up there. If there are questions, I'd love to talk more about how we built this or anything came up in the session. But yeah, I'll wrap up there.
Thank you so much. This is so informative and I totally enjoyed it. We have some questions, I guess. Yeah, Aditya, go ahead.
Hi, James. Thank you for this introduction. I have been vibe coding for quite some time now and with some good success. So, let's just have this conversation, right? What is the most complex thing you have built so far using vibe coding, and how much time did it take you?
Yeah, that's a really good question because I think we can sometimes assume that, vibe coding is a very quick and seamless process. Like I've spent a long time with staff members, like trying to get them, like teachers, for example, trying to teach them how to vibe code, and that proved to be very difficult. People come in with varying levels of experience. So the most complex thing I've vibe coded, like I guess I'm a good case point example because as someone that has no prior technical experience coding whatsoever, I've really just been spending the last, I guess, few years since ChatGPT came out, seeing what's possible. And in terms of complex things, I've been slowly working away at a not this thing, but it's a sort of a productivity management tool designed for like non-neurotypical minds, so ADHD, for example, that has been like I've been working on that for about a year to sort of try and get right, and sort of yet to sort of formally launch or announce it. But that's taken over a year of just really, iterating and adjusting things and getting the settings to look, to function well, and getting the interface to look right, and changing the colors and the things, and thinking of features to, put in there and getting it to actually work. So that's been a long sort of project. Um, but yeah, that's been over a year now. So hopefully one day I'll release it. Otherwise, it might just be personal software I just use myself and never publicly release. We'll see. But yeah, thanks for the question. I think there are other questions.
Hi, James. Can you hear me?
Yes.
Thank you for the amazing talk. I wanted to ask, you mentioned about beneficial offloading. How
Mm.
how do how do we ensure that when we are vibe coding something, we make sure that uh, we are not delegating the important thinking to AI, but we are rather doing the beneficial offloading.
Yeah, so that is such a good question. So the only way I can explain it, because I've been vibe coding for the last few years, I've started to feel like it's almost like a gut instinct as to when I'm starting to um, offload things in a way that isn't beneficial. It is like a literal feeling, like it is a tangible thing where I'll start to sort of say, for example, I'll start to follow some AI suggestions on an app that I'm building, right? It'll come up with some ideas, and I'll explore those sort of absent-mindedly almost, and I'll add them in. Oh, that looks good, and then I'll keep adding it in, and sort of following that rabbit trail. And all of a sudden, what I started off building now looks very different, and I haven't really been thinking about the purpose of it, or why I'm building it, or who it's for, or what it's trying to do. And you are literally just switching off and just being guided by the AI suggestions. So the only way I could describe it is, I guess, the more you do it, the more you start to really get a sense of when you're cognitively um, aware and open to, or not open to, but when you're using that sort of cognitive effort to build the thing that you're trying to build, and when you're not. That's the only way I can really explain it. It's almost like a physical sensation. But the challenge then is, how do we get students to do that? How do we get them to use the guardrailed educational, pedagogical generative AI tools that we've made for them? How do we get them to use that, and not just cognitively offload stuff that is detrimental to them? That's kind of going to be a challenge. But yeah, great question. Hopefully that answers it.
Yeah, thanks. And I have one more question. Uh, do you think that for education and AI tools, is text the right medium, or should it be
Mm,
video? Like if you see the latest examples from Notebook LM, where you
mm,
upload a topic and you get a very good video lecture,
mm.
but then also that video lecture is static. But what if it is some sort of a proactive
Mm.
video that you can interact with, and that video can interact with you and ask you questions. So do you think that would be a better medium of learning, or
Mm.
for students?
Again, another great question. I think that what we're dealing with at the moment is sort of the new era of EdTech in a very early phase. We are dealing primarily with, when we talk about EdTech now, we usually just mean a chatbot for the most part, which will probably, I'm guessing, will eventually change. We know that with Carmigo, for example, and I've seen this with my own educational tools that I've developed. We see that students don't really want to engage with the chatbot experience. They're sort of disengaged. They'll type. This is something that Sal Khan was talking about recently. Like students will just type in like IDK into the chatbot. I don't know. They weren't really fully engaged with it like they would a human teacher teaching them concepts. And that might largely be in part due to the fact that they're typing out this stuff. And we often hear about the Socratic method and how students are meant to learn with AI tools. We don't want the AI to give them the answers, blah blah blah. We know all this, but I don't know if the Socratic method works as well in a chatbot experience where you're typing out your answer. Like it just feels a bit flat. So if anything, I've found the voice mode element of using a sort of generative AI tool is really beneficial to the Socratic experience. Being able to just talk to the AI itself, or at least not even have it talk back to you. It's okay if the AI responds in text, but at least if you're talking to it verbally, I find that sort of speaks more to the Socratic experience we want students to engage with, rather than you sort of typing it out. But I do expect that as the technology develops, we'll probably start to move away from the chatbot interface to other mediums. And yeah, whether it's video or audio, or more even immersive sort of VR sort of settings. I'm more than confident we'll probably see a change. Are there any
Uh,
other questions? Aditi, yeah, you've
yeah,
got your
yeah,
hand up.
I do have a lot of interesting questions, So, again, because you mentioned you have been vibe coding for a year, or like more actively, and for a few years, just concentrating on your main project. How big is the code base, right?
Yes, so this is a good question. At the moment, so this is one of the things I learned early on in as a vibe coding person. Um, the app TSX file, which is not a file that I knew existed, 3 years ago, had about 1900 lines of code in it. And I realized very quickly that was slowing things down a lot. And it was like trying to find a needle in a haystack whenever I wanted to edit or fix the code that I was working with. And so that was kind of my first lesson in sort of real coding, I guess, was that you've got to make sure that app TSX file doesn't overinflate. And often that's exactly what happens when you're vibe coding, that the AI just puts it all into that same file. And I had a really cool experience with at the time it was I forget which model it was. Oh, it was Claude Opus 4.6, and I asked it just refactor this 1900 lines of code for this app that I designed. And in one shot, it just refactored the entire thing. Previously, this is a task that Google's Gemini 3.0 or 2.5 really struggled with. It just couldn't refactor it. It kept breaking. But in one shot, it just did it. So to answer your question, I think the code base at the moment is all out. I think it's like 5,000 lines of code. There's a few like API calls in there, and a lot of the code is really the instructions that we've given it, the very weird specific instructions around like preventing students from cheating, the sort of the roles we assign it around being Socratic and switching into explicit mode, those sorts of things. But I think that's sort of, it sits about a couple of thousand lines of code at the moment.
Okay. And I mean that's interesting because I come from a software architecture background. And you know, I mean, 4,000 lines of code is I mean, it's a small code base
Yes.
by yeah. Okay, thank you for that, James. That's a good feedback. I would love to connect. You know, I mean, some insights I have to share. Maybe I can share those more personally, right?
That sounds great. Yeah, love to connect. That sounds awesome.
Sure.
Any other questions?
Yeah, we have some questions in the chat box. I can read it for you if you cannot see them.
I can't see. Oh, there we go. Sorry. Yeah, I didn't have a chat box open. Oh, wow, the chat's going off. Okay. Are there any empirically validated indicators to detect when offloading is starting to damage more than benefits? In terms of detrimental offloading, good question. I don't know the answer to that right now. There might be research on that. Harsha, oh, that's not important. What educators build through vibe coding? Any concrete examples? I guess this is a concrete example. Sorry, that was probably asked ages ago. So, but the math assistant would be a concrete example. I've seen I think this is a really good question actually, because we don't see a lot of use cases talked about. But vibe coding doesn't necessarily, with teachers, for example, doesn't necessarily always have to look like an app or a web app or a service. I've seen teachers vibe code their course materials. So we had a session where teachers were putting in their course outlines, which is like the sort of document that tells students what's in the course. They were putting their course outlines into Google's AI Studio and developing a sort of UDL framework, which is a universal design for learning, to make that course outline a bit more palatable. And using certain colors and templates and various mediums, audio and visual, it created these really nice, beautiful aesthetic UDL principle aligned course outlines. And there was some back and forth prompting that was going on. But again, another example of like a sort of a task that you would often maybe never have the time to do, which can be sort of streamlined with the use of natural language and a chatbot, allows teachers to make these resources that they never could have made previously. So yeah, hopefully that answers your question. But we do need more examples, I think, out there. And there's people working on this at the moment. I know Simone Hirsch, who's based in Australia, is working on a big project around collecting use cases within education for vibe coding, and that's from K to 12 all the way to university. So she should be releasing that soon, I believe, if you follow her on LinkedIn. I think that's all the questions.
Math assistant is also a good example.
Yes, yeah, obviously, yeah, I mentioned that. I think Math Assistant is a good practical example as well of what you can do when you get teachers together in a room. And even what was interesting with Math Assistant was even teachers that were previously like anti-AI or not really into the whole using AI for learning, they were actually won over by being part of that process of building out that Math AI bot. And their feedback was invaluable because they were teachers of mathematics and they knew where students could fall flat, and they were able to offer that feedback as part of the build. And then they were on board. They thought it was they thought it was great. They're very excited about it. So I mean, they were happy to embed it in their course. So that's always a good thing. But
Yeah, that's super cool because there was a barrier first, and now the barrier has been removed, and educators can just make the tool that would really, really help themselves and the students as well. So yeah. Thank you so much, Dr. James. It was a perfect session. I thoroughly enjoyed it. So yeah, I think that's that were all the questions.
Looks like it. Thanks for having me. Thanks, guys. And yeah, if anyone wants to catch up, please do. I'll put my email in the chat. We can yeah, happy to connect.
Pleasure having you. Bye bye.
All right, bye all.